Hello friends, welcome to the software engineering subject. In this video lecture, we are going to learn your first unit, that is Introduction to Software Engineering. So, our first question will be there, what is software engineering? So before starting with the software engineering whole term, we can understand both the terms software plus engineering individually. So our first question is, what is software? So definition says software is a set of computer programs that provides functionality and performs desired tasks. Or technical definition says software is combination of three things. First one is instructions, second one is data structures, and third one is documents. Instruction, what is instruction? So instruction is a computer program which provide desired function and performance while executed. Instructions means our programs. Data structures, that enables program to effectively handle the informations. And third is document, so that describes the operation and use of programs. So this is information about what is software. Now let's check different examples of software. So examples are operating systems, internet browsers, movie player, antivirus, game, etc. So Windows 10 is operating system, Google Chrome is internet browser, VLC media player is a movie player, McAfee is antivirus, and Free Fire is a game application. So these are the all softwares that we use in our real life. Now our second term, that is what is engineering. So the process of designing and building something that serves a particular purpose, that will be known as a engineering. So in combination of software plus engineering, there will be a software engineering. Okay, so in combination, what is software engineering? So is the science and art of building a software system that are on time, on budget, with acceptable performance, with correct operation. A systematic approach to the development, operation and maintenance of desired software. So that is software engineering. Now let's learn product development from an IT failure perspective. So this is example where how customer explain to the developer team, how product leader understand, how the analysis design it, how the programmer wrote it, how the project was documented, what is the beta tester received, what operation installed, what the customer really needed, how the perform under load, and how the customer was billed. So with starting this phase, ending with this phase, all the stages are inappropriate with each other, means there are some lags between some different levels of information passing. So this is the main failure of IT perspective. Okay, now let's learn about the evolving role of software. So software plays dual role, first one as a product and second one as the vehicle of delivering a product. Okay, so as a product, it producing, managing, acquiring, modifying, displaying and transmitting information. So this is as a product, and as a delivering product, the control of computer, communication of information, correction of other programs. So these two roles software plays mainly. So we can say these are the producing, managing, acquiring, modifying, displaying. These are as a product, and vehicle for delivering a product means if we use operating system, then and this operating system we can install this type of software. Networking software, this type of software we can connect with this type of networking software. And for managing, or we can say so for production, we need our software tools. So software plays dual role as a product also and as a vehicle for delivering a product also. Now software applications. So software categorized based on their application areas, which are software, system software, business software, engineering and science software, personal computer software, web-based software, artificial intelligence software, real-time system, and embedded system. So what is system software? So system software interact with hardware and provides interface to the other applications. Its example are operating system, device driver, compiler, file management utilities, etc. Now let's see its applications. So Windows 10 is an operating system, NVIDIA is a device driver, Turbo C, we can use compilers for Turbo C, and file manager is a file management utility. So this type of software will be known as a system software. Second one is business software. So software application that used by business user to perform various business functions, that will be known as business software. So applications are Tally and SAP. For accounting system, enterprise resource planning, we use Tally and SAP. So that are the examples of business softwares. Third one is engineering and scientific softwares. So number crunching algorithm used to solve scientific problems. For that we use MATLAB and AutoCAD. We all know that for engineering and scientific we use MATLAB and AutoCAD. So these are the examples of engineering and scientific softwares. Next is personal computer software that we use in our personal computer. So which are the word processing software, spreadsheet, multimedia software, that all are the personal computer software. We all use Microsoft Word, Microsoft Excel, Windows Media Player, VLC Player. So that all are the personal computer softwares. Next is web-based softwares. That software which run through only and only web. So that will be known as web software. Web pages retrieved by web browser, or we can say application, that is a web-based software. Google, Facebook, LinkedIn, these all are the example of web-based softwares. Sixth is artificial intelligence software. So computer system able to perform tasks normally requiring human intelligence. Examples of AI are video games like Far Cry, virtual assistants like Siri, Alexa, Cortana, CRMs like chatbots, entertainment like Netflix and YouTube, automobiles like Tesla. These all are the examples of artificial intelligence, or we can say AI softwares. Seventh is real-time system. To monitor, analyze and control the real-time events, we use real-time system. So for that, vehicle event controller, radar, aircraft controlling system, that all are the example of real-time system. Here airbags are the real-time system. This is the Google car, that is the example of real-time system. And 8 is embedded system. So resides in read-only memory of a device and used to control its functions. So keypad control for a microwave oven, digital function in an automobile such as fuel indicator, dashboard display and braking system. So these all are the examples of embedded system. This system are the example of embedded system. So these are the types of softwares. Okay, now let's check software characteristics. So software is a logical rather than a physical system. Therefore software product has characteristics that are considerably different than hardware. Definitely that will be different from the hardware. So first says software is developed or engineered. It is not manufactured in the classical sense. We manufacture our physical product, but we develop or engineer our software. Second is software doesn't wear out. Wear out means break. Our any physical product can break, can wear out, but our software doesn't wear out. Our bike will have an accident and it will broken, it will be wear out, but our software doesn't wear out. Third, although the industry is moving towards component based assembly, most software continues to be custom built. So that we all use custom built software. So this is characteristics of your softwares. Now let's check our hardware failure curve. So this is the hardware failure curve. This is the starting time and this is the ending time. This is the starting time, means before manufacturing. This is the zero effect, means that is not in used. If we start we use, then day by day it will have some problems, and after some year it will stop working, means it will wear out. Each and every hardware product will have some time limits. In that time period that will wear out, or we can say that will break. So this is the hardware failure curve. This is the starting time, means no development, no manufacturing. Time by time it will be developed. After developing it will be worked, and after some time it will wear out, means it will fail. So this is the hardware failure curve. Now what is software failure curve? So this is a idle curve. Green one is the idle curve for the software, means if we have not engineered or not developed the software, then effect will be zero. But if we develop, if we engineered our software, then it will not wear out, means it will be work continuously. But this is the actual graph. Day by day it will have some changes, like some configuration changes, some system requirement changes. So it can stop work, but with some changes we can start working it again. So this curve is a actual curve, this curve is a idle curve for the software failure curve. Second one is software engineering, a layered technology. So this thing we will learn in our next video lectures. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you friends.